section P5, factoring polynomials. Again, some Algebra 1, Algebra 2 review. The video that we will look at tomorrow will have a little bit more. You might not have so much work with looking at factoring polynomials in terms of some perfect cubes or difference of cubes. So there will be some new stuff a little bit more in the next video, but don't disregard this one just because I said that. So looking at factoring out the greatest common factor of a polynomial, factor by grouping, factor trinomials, factor the difference of squares, factor perfect square trinomials. That's about where we're going to get to today. And then we'll look at factoring the sum or difference of two cubes, use a general strategy for factoring polynomials, and factor algebraic expressions containing fractional and negative exponents. So that is definitely some new stuff there. All right, so factoring polynomials. Factoring a polynomial expressed as the sum of monomials means finding an equivalent expression that is a product. The goal in factoring a polynomial is to use one or more factoring techniques until each of the polynomial's factors, except possibly for a monomial factor, is prime or irreducible. In this situation, the polynomial is said to be factored completely. So first step is always to look for that greatest common factor. The greatest common factor, abbreviated GCF, is an expression of the highest degree that divides each term of the polynomial. So for example, factoring out the greatest common factor, look for that GCF first. So if we have a 10x to the third minus 4x squared, we're obviously looking at what's in common. So if I have a 10 and a 4, they're both even numbers, so I can factor out a 2, and there's nothing bigger than a 2. Then when I look at my values or my exponents, I have my variable to the exponent, x to the third and x to the second. What is the greatest number of x's in common? So if I have x to the third and x to the second, they each have x squared in them. So that's going to be the greatest common variable factor. So 2x squared is in common in all of those. And then when we factor that out, 2 times what gives us 10? Well, that's 5. X squared, how many more x's do I need to get to x to the third? I need a single x, and then I have minus, and 2 times what would give me 4? 2 times 2 would give me 4, and I already have an x squared out there, so I don't need any more x's. When in doubt, multiply it back out, make sure that it works. If I look at the second example, I have a 2x times the quantity x minus 7 plus 3 times the quantity x minus 7. Well, in this case, what's in common? Well, they both have an x minus 7 in common, so that's what gets pulled out to the front. It has to stay in the parentheses. And then once I take those out, what am I left with? I'm left with a 2x and a plus 3. So greatest common factor may look a little different in some cases. Factor by grouping. So some polynomials have only a greatest common factor of 1. However, by a suitable grouping of terms, it still may be possible to factor. This process is called factoring by grouping. So for example, if we have an x to the third plus 5x squared minus a 2x minus 10, there's nothing in common in all 4 of those terms. So to group means that we would take and we would group these first 2 pieces together and the second 2 pieces together. So if I look at what's in common with an x to the third and a 5x squared, I have an x squared in common, and if I factor that out, x squared times x gives me x to the third, and x squared times a positive or a plus 5 would give me that 5x to the second power. Now when I take my next piece, I'm going to again look for what's in common, but my goal is to make a factor that looks like this x plus 5. Well, a minus 2x and a minus 10 can be made into an x plus 5 with a common factor of negative 2. So if I factor out a minus 2, a negative 2 times x would give us that minus 2x, and a negative 2 times a positive 5 would give us that minus 10. So now we have that common factor of an x plus 5, and whatever's left over when I take those out is an x squared and a minus 2. Now, we always double check to make sure that's in simplest form. And maybe something like this might have struck a little, hey, I need to double check. Anytime you're left with an x squared, always double check to see if it's something that could be simplified further. If this were like an x squared minus 1, that would be a special case. Special case meaning you would have had an x plus 1 and an x minus 1, since we just went over multiplying some of our special binomials, we end up with a special type of answer. So if that's an x squared minus 1, x squared minus 4, x squared minus 9, etc., that would be one of those special cases you'd have to watch out for. Since that is not the case, right, we don't have to worry about that. This is our final answer. So factoring trinomials of the form ax squared plus bx plus c, they have a strategy for factoring our trinomial. It says assume for the moment that there is no greatest common factor. So number 1 says find two first terms whose product is ax to the second power. Find two last terms whose product is c. And then by trial and error, perform steps 1 and 2 until the sum of the inside-outside products is bx. So you look for all your possible ways to make your ax squared. You look for all your possible multiplication, all your products of c. And then you're kind of looking for kind of a game of guess and check, right? Start mixing inside-outside terms to try to fill in the blanks, right? So it tells us that the sum of the outside and inside terms is what that b value is. It says if no such combination exists, a polynomial is prime. So let's look at an example, and I realized in this set of notes I do have a couple typos, so you're going to have to help me out. It says to factor x squared plus 13x plus 40, but then the typo, that's not the same problem. So step 1 says to find the first two terms whose product is x squared. So the only way to make x squared is x times x. That was an easy one. Step 2 says to find two last terms whose product is 40. So if you go through and kind of figure out all your factors of 40, we would have a 1 times a 40, we'd have a 2 times a 20, we'd have a 4 times a 10, we'd have a 5 times an 8. Once you have all your factors of 40, it says try various combinations of these factors, and we're looking for the pair of factors whose sum is 13. Sum meaning that we are adding to make 13. So if I go back here and I take a look, if I add 1 and 40, that's 41. If I add 2 and 20, that's 22. If I add 4 and 10, that's 14. If I add 5 and 8, that's where we end up getting the 13. So the two terms, or the two factors that multiply to make 40, that add to make 13, are going to be that 5 and that 8. So for instance, our final answer for that, I don't think for some reason there is a final answer. We end up with an x with a 5. We'd end up with an x with an 8. And then because these are all positive in terms of the 40, that means that they're the same sign, and this plus sign tells us that they are positive signs. So we'd end up with an x plus 5 and an x plus 8. So the difference of two squares, I kind of mentioned this already when we had to check that one problem to make sure it was finished. It says if a and b are real numbers, variables, or algebraic expressions, then a squared minus b squared is equal to a plus b times a minus b. It says in words, it's the difference of the squares of two terms, factors, as the product of a sum and a difference of those terms. If you remember, we talked about inside and outside terms, and in this case you'd have an outside term of a positive AB and an inside term of a minus AB, which is where that middle term cancels out. So an a squared minus b squared is going to be in the form of whatever that number is times itself, the square root of a and the square root of b. And then you have one as a plus sign and one as a minus. So for example, we have a 36x squared minus 25. So if I were to think about 36x squared, well, what is that? Well, that's a 6x times itself. And if I have a 25, I have a minus here, that would be a 5 times itself. So we are in the form of a squared minus b squared, which means we're going to end up with a 6x with a plus 5 and a 6x with a minus 5. And when in doubt, FOIL it out, right? First, outer, inner, last. Make sure that that middle, inside, outside terms cancel. The next example, they tell us that we have a repeated factorization. So in this case, we have a little bit more than one step to do. It says to factor completely, we have an 81x to the fourth minus 16. So if I look at 81x to the fourth, well, that's going to be a 9x squared. That's squared. To get x to the fourth, 2 times 2 is that 4. Remember the parentheses in between tell us to multiply those exponents. And then we have minus 16 is made up of a 4 that's being squared. So that means we have a 9x squared minus 4. We have a 9x squared plus 4. Whichever order you want to go in, it doesn't really matter. One's plus and one's minus. Now, before I move on, I need to make sure that's simplified. Remember I said if you have an x squared, always double check it. Well, this first one over here, that has that x squared and it has that minus sign, which means we get to do this all over again. So if we have a 9x squared, well, that's a 3x that's squared. And we have a 4 that's minus 2 that's squared. That means we have a 3x minus 2. We have a 3x plus 2. And that 9x squared plus 4, because that's a plus, I cannot do anything further with it. So that just stays as a 9x squared plus 4. Always make sure you have a final answer. And that cannot be simplified further. So factoring perfect square trinomials says let a and b be real numbers, variables, or algebraic expressions. So here's our other special case. If a squared plus 2ab plus b squared, that's going to equal a plus b squared. Same thing with our a squared minus 2ab plus b squared. That's our a minus b squared. The thing that determines the sign, right, is with that middle term. The middle term can be expressed as twice the product of a and b. Let's take a look. We have a 16x squared minus a 56x plus 49. So to check if this is a special case, we would check our 16x squared, which is a 4x, that'd be squared. 49 is a 7 times itself. And if I take a 4x times a 7 and I double that, 2 times 7, that's 28. 4 times 7, 28 with the x. That gives us a 56x. That tells us that we have our special case. And because we have that minus in there, that means that we're going to have, wow, sorry about that. There's a special spot on my iPad that sends it all the way back to the top. So we would end up with a 4x minus 7 and a 4x minus 7, or we simplify that down by a 4x minus 7. That would end up being squared. And that's where we're stopping for today.